Welcome to learning about the quadratic formula. So we already learned one method into solving a quadratic equation, and that's through factoring. Now sometimes you can get a quadratic equation that you can't actually solve by factoring, that it's actually unfactorable. If that's the case, we have a fancy formula you could use to solve for x instead. And here is the following formula. So usually you are solving for x, so that's what that first part represents. And then b is your coefficient in front of the x. A is the coefficient in front of x squared. And c is your constant. So we have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that means you always need to get your quadratic into standard form so that you can use this formula. Let's go through 2 examples and then you can try one on your own. So for the first one, 5 is going to be our a. Negative 7, we do count the symbol in front of our coefficient, so it's negative 7 is b. And then negative 1 is c. And we're just going to put this right into the quadratic formula. This minus is coming from the minus in the formula, and then b is negative 7. So b is 7, and then we squared according to the formula. A is 5, c is negative 1. Then it's 2 times a, and a is 5. Okay, so that's how we set it up, and now we just need to simplify this. A negative times a negative is a positive, so we are left with positive 7. 7 squared is 49. Negative 4 times 5 times negative 1 is positive 20. Then 2 times 5 is 10. I'm going to simplify what's inside of our square root sign. So that's going to be 69. And then that is it. So we can actually represent this as a final answer of 2 answers, because we'll do 7 plus the root of 69 over 10, and you'll do 7 minus the root of 69 over 10. And those are our 2 answers. There's 2 answers for x. And then we are done. You could also plug this into your calculator to get a decimal as well. So if you're doing this in the calculator portion of a test, then you could plug it into the calculator to get the decimal. If it's on the non-calculator section, you could just leave it as that. Okay, let's try the next one. So we need to get this into standard form before we begin. I'm going to add 4 on both sides so that our quadratic is set to 0. And then we want to solve for this. And we're going to use the quadratic formula to do that. Now sometimes if you've been trying to factor quadratic and you just can't get it, but even though it is factorable, you can still use the quadratic formula. You can even use the quadratic formula for factorable quadratics. You'll still get the same answer in the end. But factoring is probably just a lot faster than using your quadratic formula. All right, so going back to b, our b value is 12, our a value is 9, and our c value is positive 4. So you have negative 12 plus or minus 12 squared minus 4 times 9 times 4 all over 2 times 9. Twelve squared is 144. 9 times 4 times 4 is also 144. And 2 times 9 is 18. So 144 minus 144, that means this whole term is just gone. And we're left with negative 12 over 18. So there's only one answer for this one. We can simplify this fraction, and that's 2, negative 2 over 3. And then we are done. So you can have two answers, you can have one answer, you can even have no solution, so 0. And we're going to do that later on. So try C first on your own. My little hint to you is expand and then rearrange it so it's in standard form where your quadratic is set to 0. And then when you're ready, press play to see the solution. Here is the solution to C. So the first thing I did is on the right hand side of our equal sign, I expanded. So I did 3x times x, 3x times 1, negative 3x, and then negative 3 times 1. And then I collect my like terms. And I moved our 2x on the left side to the right side. Now we can go ahead and plug this into the quadratic formula. Your a is 3, your b is negative 2, and your c is negative 3. And then you plug it into your formula. You're going to simplify it. And then the tricky part is when you get to over here. You can leave your answer like this if you wish, but it's not in the simplest form. What I did here is simplify my radical. So we know 40 can be represented as 4 times 10. That's the same thing. I also know what the square root of 4 is. It's 2. So that's what I did from here to here. I took the square root of 4, which is 2, and left on the outside of the radical now. And now, between all of our terms, we have a 2 in common between 2, 2, and 6. So divided by each term by 2. And that's how we got our final answer. Okay, now let's do D, and this time we have fractions. We can get rid of our fractions if we multiply both sides by 6, because that is our biggest denominator. Before I do that, I'm going to move this 5 over 6x to the other side so we can get this into standard form. Okay, so I just moved this 5 over 6x. Okay, now I can multiply both sides by 6 because that would get rid of all the denominators we have. And it's also a common factor between 3 and 6. Okay, so I'm going to go ahead and multiply 6 with every term. 6 times 2 over 3 is 4, then minus 5x plus 6. This is still equal to 0 because 6 times 0 is 0. Now we can plug this into our quadratic formula. Now, if you try to simplify what's inside the radical, you're going to see that you're going to get a negative number. If you ever get a negative number inside the radical, that means there is no solution. There's no x value that's going to satisfy this. So this gives a negative value. We're unable to take the square root of a negative number. So that means we have no solution. So your various type of answers could have 2 solutions, 1 solution, or no solution. Now we're going to apply the quadratic formula to another word problem. So Leah wants to frame an oil or original painted on canvas measuring 50 by 60 centimeters. Before framing, she places the painting on a rectangular mat, so the uniform strip of the mat shows on all sides of the painting. Okay, I'm going to draw our canvas first. So we can see that this is 50 by 60 centimeters. And we know that there is a strip that goes along all sides of the mat. And it says uniform, so we know that our length and width of everything is going to be the same. So if I were to draw this in, that means that this length here is going to be X. Same thing with this. Same thing with this, and so on. The next piece of information says the area of the mat is twice the area of the painting. And then we want to know how wide is the strip, so we want to solve for X. And then we want to round to the nearest tenth of a centimeter. Well, we already know what the area of the canvas is, so talking about this, the area of the mat is twice the area of the painting. So the area of the painting, we'll call it AP, is 50 times 60, because that's length times width for a rectangular object. So 50 times 60 is 3,000. That would be our area of the painting. So that means the area of the mat is twice that, which is 6,000. The next part is to set up an equation to describe the area of this mat. If we look at our height or length and your width of a mat, this is going to be 50, because we already know the length of this one here, plus the 2 x's on either side. So plus 2x. So we have an x on each side, and we need to add that towards the length. Now for the other one, same sort of thing. We know from here to here is 60, but we also need to add this x and the other x. So that's adding 2x. So that is the length and the width of our mat. So we know the area of the mat, which is 6,000 centimeters squared, is equal to the length times width. And now we're going to solve for this. So I can solve for x. I'm going to rearrange this again so that we can set our quadratic equal to 0. I'm also going to expand, so I'm going to multiply our brackets out. So 60 times 50 is 3,000. 2x times 50 is 100x. 60 times 2x is 120x. And then 2x times 2x is 4x squared. Now I'm going to collect my like terms and rearrange. And then when I do that, I'm going to get 4x squared plus 220x minus 3,000. Before we begin to use the quadratic formula, I'm going to factor out a 4 first, because there is a 4 in common between all three terms. So once I do that, I'm left with x squared. 220 divided by 4 is 55. 3,000 divided by 4 is 750. Now my a is going to be 1, my b is going to be 55, and my c is going to be negative 750. Now I'm going to put into the quadratic formula. And solve. In this case, I will just plug this into the calculator so I actually know what value my x is going to be, because we're talking about a length. So if you do negative 55 minus the square root of 6,025 over 2, you're going to get a negative number. Now, does that make sense when we're talking about a length? Not really. So we're not going to calculate that one, and if we do, we're going to get this, but we're going to discard that right away because we don't want a negative length. Once you do negative 55 plus the root of 6,025 over 2, you're going to get positive 11.3. This is the value we want to take. It's positive, and that is our x value. So x is 11.3 centimeters. And that is the width of the strip of the exposed mat.